Hello friends, in this video we are going to solve a question of theory of computation which is also useful in the GATE exam. Let's see, this is our question number 8. We have CFG is not closed under A union, B clean star and C complementation and D product. Let's see, as we know that context-free grammar is not closed under complementation, set difference and intersection, and context-free grammar is closed under union, concatenation, clean closure, reversal, product, etc. So the correct option is C, complementation, because we have to find on which the CFG is not closed under, so it is not closed under complementation. Let's move to our next question, that is our question number 9. The set A is equals to A raised to n, B raised to n and C raised to n, where n is 1, 2, 3, is an example of a grammar that is regular, context free, non-context free and none of the above. So we have to find that this set A is example of which type of grammar. Let's see, the language A raised to n, B raised to n, and C raised to n, where n is 1, 2, 3, is known as the language of balanced parenthesis, where each A is followed by the same number of B's, which is then followed by the same number of C's, as it is A raised to n, B raised to n, and C raised to n. So power of n is 1, 2, 3, and it is same for A, B, C. That's why they have equal number of A, B, and C. Let's analyze the given option. Option A, regular. Regular language can be recognized by finite automata and they are closed under union, concatenation and clean star operation. However, the language A is not regular because it requires counting the number of A's, B's and C's, which cannot be done with a finite automata. Let's go to our next option. We have context free. Context free languages are generated by context free grammars and they can be recognized by push down automata. The language A can indeed be generated by a context free grammar. For example, CFG as gives A as BC where and empty, B gives B, capital B and C and empty also, and C gives C, generates the language A. Therefore, the language A is context free. Fine. Then we have option number third, non-context free. Non-context free languages are languages that cannot be generated by context free grammars. While the language A is more complex than regular languages, it can still be generated by a context free grammar as shown in option B. Therefore, the language A is not an example of non-context free language, and none of the above this option is not correct because the language A is indeed context free, which is our option number B. Therefore, our answer is B, context free. Let's move to our next question. That is our question number 10. We have three sets L1, L2 and L3, A raised to n, B raised to n and A raised to m, where n and m is equals to 1, 2, 3. Language 2 we have a set A raised to n, B raised to m and A raised to m, where n, m is also 1, 2, 3. And language 3 is also a set A raised to n, B raised to n and A raised to n, where n is 1, 2, 3. We have to choose the correct answer, that is L3 is equals to L1 intersection L2. B option, L1 and L2 are CFL but L3 is not CFL. Third option, L1 and L2 are not CFL but L3 is CFL. And fourth option, L1 is a subset of L3. Let's see what we have. A option A, what it says, L3 is an intersection of L1 and L2. Fine, we have L3, A raised to n, B raised to n and A raised to n, where n is 1, 2, 3 and we have L1, L2. To find the intersection of L1 and L2, we need to find strings that are common to both languages. However, L1 contains string to form A raised to n, B raised to n and A raised to m. This string will be formed by L1, and L2 contains strings of the form A raised to n, B raised to m and A raised to m. This string will be formed by L2, which are different from the strings in L3, that is A raised to n, B raised to n and A raised to n. Therefore, L3 is not equals to L1 intersection L2. So statement A is incorrect. Second we have Option B, L1 and L2 are context-free languages, CFL, but L3 is not a CFL. L1 and L2 can be generated by context-free grammar, CFGs, as they are well-defined structure. However, L3 cannot be generated by a CFG because it requires counting the number of A's and B's, which is beyond the capabilities of CFG. So, statement B is correct. Let's see another statement. Statement or option third, L1 and L2 are non-context free languages, but L3 is a context free language. As discussed in option B, L1 and L2 are context-free languages, but L3 is not. So, therefore, statement C is incorrect. We have fourth option, L1 is a subset of L3. This statement is incorrect because L1 contains string of the form A and B and A, means A raised to N, B raised to N and A raised to M, where the number of A's and B's are equal followed by the number of A's and M's respectively. However, L3 contains strings of the form A raised to N, B raised to N and A raised to N, where number of A's, B's are equal followed by A's and N's respectively. Since M and N can be different, L1 is not a subset of L3. So statement D is incorrect. Therefore, the correct answer is B, that is L1 and L2 are CFL, but L3 is not a CFL. Thank you.